These are the solutions to the predicted paper for the paper 4 in May 2025. This is just my best guess of what's likely to be on the paper, but obviously if you have time you should also try and revise some of the other topics as well. Either way, good luck with it. I hope you all get the grades that you want and that you deserve. Question 1 is a time question. Now with these, I don't recommend trying to do it like a calculation that you're going to put into your calculator. A nice way to try and do it is by doing it in a few jumps. The first jump I'm going to make is maybe from 9:50 until 10 o'clock, and that is a jump of 10 minutes. And then let's go from 10 o'clock all the way through until 5 a.m. So that's 2 hours until midnight, add 7 until 5, so that's plus 7 hours. And then from 5 a.m. to 5:18 is obviously going to be another 18 minutes. So in total we've got 7 hours and 28 minutes. The second question is a factorise fully. Okay, so first of all, I'm going to try and make this as a single bracket, so I'm going to take maybe a 3 out of both of these, leaving me with 9y squared minus 1. And this is 3 marks, so that doesn't seem like enough for 3 marks. So then you've got to look inside this bracket, and hopefully you've spotted that this here is the difference of 2 squares. 3y plus 1 and 3y minus 1. So there we go, that is factorised fully. This next one here, you can find plenty of examples of these questions on my website. So first of all, you might try and factorise this as a single bracket, but then you'd realise there's nothing that really comes out of both of these. So what I'm going to do first is maybe a little bit of rearranging. I'm going to put one of the other terms next. Maybe I'm going to put the plus 2k next, and then let's put minus pk minus pm. And now let's see if we can do 2 single brackets and see if it's any better. First I'm going to take 2 out of these first 2 terms, and in the brackets I get m plus k. And for these 2, well, I suppose I can take minus p out of both of these, and in the brackets I get k plus m. You can see that these 2 brackets are the same. Maybe it helps you realise that if I just reorder them, so instead of writing k plus m, I could write m plus k. And then you can see this is like a little bit like when we factorise a quadratic. So one of our brackets is going to be 2 minus p, and the other bracket m plus k. And you might think, well, what if I'd have chosen to put it in a slightly different order? Well, we should still have ended up with the same answer. There's a few ways we could have come up with exactly this same thing here. The trick is to kind of play with it a little bit until you can get something that fits into 2 brackets like that. Question 3 is a currency conversion question. First I'm going to write the exchange rate here. £1 equals $1.19. And then underneath I'm going to write this $380.8 on the same side as the dollars, so 380.80. And I need to work out what I'm multiplying by here. To do that I'm doing 380.8 divided by 1.19, and that gives me 320. So that tells me that I need to multiply here by 320. So I'm going to do the same on this side. And 1 times 320 is 320, so that means it is £320. Last question on this first page. The angles of a triangle are in the ratio 2 to 3 to 7. Find each angle. Well, first of all, we're going to add up the parts of the ratio. 2 plus 3 plus 7 is 12. And we know that the angles in a triangle add up to 180. So now let's do 180 divided by 12 to find out how much we've got in each part of the ratio. That's 15. So now I'm going to write my ratio again, 2 to 3 to 7, and I'm going to multiply every part of that ratio by that 15 there. 2 times 15 is 30, 3 15s are 45, and 7 15s are 105. Let's just check they add up to 180. 105 add 45 is 150, add 30 is 180. So yeah, that seems okay. So 30 degrees, 45 degrees, and 105 degrees. Next we have quite a common simple and compound interest question. Part A is simple interest. So Zach's investing $500 at a rate of 2% simple interest, so we're going to find 2% of 500 by doing 500 times 0.02, and that is 10. He's investing it for 5 years, so we're going to do 5 lots of 10, which is 50. Okay, now that's the interest that he's earning. The value of his investment includes the original amount, so I need to add on that 50 to 500. So the value of his investment is 550. Yasmin invests at compound interest, so quite a different way of calculating this one. So our compound interest formula, 1.018 to the power of 5. That's something you should be familiar with. We're going to type that into our calculator, and that gives me 546.649. We always want money to 2 decimal places, so that's $546.65. Part 3 is a little bit trickier. So we want how many more complete years is it before the value of Yasmin's investment is greater than the value of Zach's investment. I think probably the easiest way to do this one is maybe just by a bit of trial and improvement. I'm going to do a little table to help me. So what we've got at the end of 5 years is that Zach was on 550 and Yasmin at 546.65. And I'm going to try a few numbers, so I'm going to try maybe 10 first. Now Zach's is always going to be easy to figure out because that's going to be 10 lots of 10. So instead of adding on 50, we're going to add on 100, so that would be 600. For Yasmin, I'm going to change that power of 5 to a power of 10, and that gives me 597. So that's not enough. I'm going to go up by 5 again. Let's try 15. So Zach's is now going to be 650. For Yasmin's, that's 653.41. Okay, so Yasmin's is now higher. Let's try a few more numbers lower down. So let's try maybe 13 and see how that works. So at 13, Zach's will be 630. And Yasmin's is 630.51. So again, Yasmin's is bigger. So the only one I'm just going to double check now is 12 and check that 12 is smaller. So for Zach, 620. For Yasmina, 619.36. So that means the first year when it happens is after 13 years. Careful though, in the question it says how many more complete years. So in this question it was already at the end of 5 years, so that is 8 more complete years. Okay, we're told the interior angle of a polygon is 140 degrees. I'm going to do maybe a quick sketch of that situation. So there we go, that angle there is 140 degrees. We want the number of sides of the polygon. Well, the most useful thing to know if we're working with the number of sides is actually the exterior angle instead. Okay, so the exterior angle would be 40 degrees because they have to add up to 180. And now all I need to do with that, the exterior angles always add up to 360, so I'm going to do 360 divided by 40. Which gives me 9, so that means there are 9 sides. Next is a stem and leaf diagram where it's mostly drawn for us, including the key. So we're going to start with any numbers that begin with a 1. There we go, we've got 18. Next, numbers that begin with a 2. Okay, well, I can see two 20s, so let's fill those in first. Then I can see three 21s. So 1, 1, 1. Now these numbers need to be evenly spaced, remember, because it's supposed to look a little bit like a bar chart when we look at it side on. Next is this 22. And then 25. And I think that's it for the 20s, so now on to the 30s. So 30, again make sure that's nice and in line. 33 next. And then 34. Let's check we've crossed everything out and check we've got the right number. There should be 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. Okay, for the median, if we've got 11 pieces, then it must be the 6th piece of data. So 1, 2, 3, 4, 5, 6. So the median is 21. They want you to make the mistake of just writing 1 there. Don't do that mistake. Now we want the interquartile range. So we want the lower quartile, which is like doing the median of these first 5 numbers, which is 20. And then we want the upper quartile, which is the median of these higher 5 numbers. So which is that, 30. And the interquartile range, as it sounds, is the range between those two quartiles. So 30 subtract 20, which is 10. Moving on to some slightly trickier questions here. Okay, we're going to make x the subject. So to do that, first of all, let's get rid of this fraction, multiplying both sides by 3x. So we've got 3xy equals a minus x. And you should have noticed already that we've got two x's. When we've got that situation, we need to get both terms with x on the same side. So 3xy plus x equals a. This is the step that people forget. Now to turn these two x's into one x, we're going to factorise. So x brackets 3y plus 1 equals a. And then I'm going to divide by this factor here. I'm going to divide both sides by that thing in brackets, 3y plus 1. So we end up with x equals a divided by 3y plus 1. Really common type of question that, which people often find difficult when there's two of the subject that we're trying to get. Okay, here we want the area of the trapezium, and this is one of the very few formulae they don't give you, so this is one that you need to know. The area is equal to half the sum of the two parallel sides times by the height between them. So that is a half of these are the two parallel sides, 5.3 plus 8.7, and then times by the distance between them, the perpendicular height, which is 3.8. So let's do 5.3 at 8.7. Which gives us 14, of course it does, and then times that by 3.8. You can now at this point type it into your calculator or simplify it further if you want. Either way, we should be getting 26.6 centimetres squared. Even though on paper 2 you did have a circle theorem question, it was quite short and I would expect there to be more. So here we go. Let's find angle BCD. Let's first of all show which angle that is. So it's that one there. Straight away you should have noticed that here we've got an isosceles triangle. So I think it would be useful to be able to find one of these two angles here. And the one we can find is this one. This one is 32 degrees. That's using angles in the same segment. That's covered in more detail on the circle theorems question part of the website. Okay, so you can find that video if you need a bit more help on that. But basically it's when you see this kind of bow tie shape here. Okay, so those two are both 32 degrees. Now I'm going to use the fact that this is an isosceles triangle, so that means that this one here is also 32 degrees, and now we've got everything we need to find that angle BCD. So 32 add 32 is 64, and then to find the missing angle I'm going to do 180 subtract 64, which is 116 degrees. This next part, a few things to notice. Well, we've got the centre of a circle. There are some shapes that we need to kind of spot, like we've got this kind of arrowhead shape here. You should know a circle theorem about that. We've also got a tangent, we've got a radius. There are potentially quite a few different circle theorems we could be using. We want to find angle AOC. Presumably they mean this one here. Okay, so what we can do already is we can figure out this angle, I suppose, by using the fact that that is 90. Is there a quicker way we can do this? Yes, we can use the alternate segment theorem. And actually this is a circle theorem that is used a lot by Cambridge. So I've got this tangent and I've got this triangle attached to it with all points on the circumference. That's what we look for in alternate segment theorem. Okay, and now I'm looking for this kind of Z shape that includes that angle, except as you'll know if you've watched my videos on circle theorems, it's not alternate angles, it's alternate segment theorem. So it means this one is not equal to this one here, it's equal to this one up here instead. So this one up here is 42 degrees. So I'm going to rub all of that out, and using alternate segment theorem we know that that's 42 degrees. And now we know that one, we know this one. Because of this arrowhead we've got the angle at the centre, which is twice the angle at the circumference. So AOC is double 42, which is 84 degrees. Like I said, Cambridge used the alternate segment theorem a lot, so if you're not familiar with it, practice it. You also had a short transformations question on paper 2, but it didn't cover much of it, so I would expect maybe a little bit more of that as well. We're going to describe fully the single transformation that maps this onto this. Okay, well, it looks like a rotation and an enlargement, but it can't be both of those things. The single transformation that it is a negative enlargement. To work out the details of it, I'm going to connect up corresponding corners. So here where this right angle is, connects up to this one where the right angle is. This corner corresponds to this one over here, and this one corresponds to this one. Okay, now this is 3 marks, so we need to write down 3 bits of information. First of all, it's an enlargement. The enlargement is a negative enlargement because it's going through that centre and out the other end. So it's of scale factor negative something. Let's just have a look at how much. So if I look at this side here, that is 2 lines long and it's 1, 2, 3, 4. So it's been doubled. So it's of scale factor -2. And then we want the centre of enlargement as well, and we found that when we did these dotted lines here. So the centre is at 4, 4 where they all cross. I would expect there to be a probability question, okay, trickier one than the one you got on paper 2. So Sarah has a bag containing 4 yellow balls and 5 white balls. She takes a ball from the bag without replacement and then takes a second ball. So this is a tree diagram question. So let's draw our tree diagram. Let's label it. So here we'll have yellow and white, yellow, white, yellow, white. This is going to be her first pick. This is going to be the second pick. And let's fill in the probabilities on the branches. So in total there are 9 balls, 4 of them are yellow. So for the first pick, nice and easy, 4 out of 9, and 5 out of 9 white. Now really important that you realise it is without replacement. So if she picks a yellow up first, that means there's 1 less yellow in the bag. So only 3 left out of 8 in total. There would still be 5 whites left in out of 8. If she picked a white first, then there's only going to be 4 whites left in out of 8, and there's still going to be 4 yellows left in out of 8. So now we've done our tree diagram, we want the probability that the 2 balls are different colours. So that's either yellow, white, or white, yellow. Those are the 2 routes we're interested in. So the first one I said was yellow, white, so that's 4/9 times 5/8. That gives us 20 over 72. And here, white, yellow is 5/9 times 4/8, which also gives us 20 over 72. Now we're going to add those 2 things up. When we do that, we get 40 over 72, which simplifies, well, it certainly simplifies to 20 over 36, but then all the way down to 5 over 9. I think you can be confident that there's going to be a question involving stuff like the sine and the cosine rule on your next paper. That's what this one is. So first we're going to show that BD equals 16.9. To do that, well, I think we're going to have to use this triangle here, because although we have this matching pair here, I don't have any other measurements. So I'm going to use this triangle and use the fact that I've got side angle side to use the cosine rule. The cosine rule is this: a squared equals b squared plus c squared minus 2bc cos a. And we're trying to work out this side here, a, and these sides can be b and c. So a squared equals b squared plus c squared, 16 squared plus 19 squared, doesn't matter which is which, minus 2 times 16 times 19 times cos of the angle A, 57. So to work out A, I'm going to square root all of that. We could work out some of these things as well if we wanted to, but I think I'm just going to type all of that into my calculator. 16 squared plus 19 squared minus 2 times 16 times 19 cos 57. Make sure your calculator is in degree mode, and sure enough I got 16.907, which to 1 decimal place, well, that 0 rounds that 9 to 9, so 16.9 meters. It's important to include that step where you show the extra decimal places when we're showing something correct to 1 decimal place. Next, we're asked for angle CBD. Okay, so before I start doing that, I'm going to store that answer. If you don't know how to do that, instead just use this slightly longer version here. Use 16.907 instead. We're not going to use this rounded number here. So let's fill that in on the diagram first. We've got that this is 16.907. And we can use that in our next question. Okay, so we want to find angle CBD. CBD, that's this angle here that we're trying to find. Okay, so I guess now we're going to use this triangle. And what you'll notice is that we have this matching pair in the triangle. And if you watch my videos on sine and cosine rule, you'll realise that that means we can use the sine rule. Only problem is when I use the sine rule, I don't know what this side is here, so I can't find that angle. But I can by working out this angle first. If we work out this one, then I know that these three angles must add up to 180 degrees. So that's what I'm going to do. We're going to use the sine rule, and we're going to find this angle over here. Okay, let's call this angle y. So the sine rule says, the sine rule for angles says sine A over A equals sine B over B. Now this is what I'm trying to find, y, so I'm going to write sine y divided by the side opposite it, 16.907, or whatever you stored in your calculator. And then sine B, that's these two here. So it is equal to sine 75 divided by 32. Let's multiply by 16.907. So I get 16.907 sine 75 divided by 32. And then I'm going to do inverse sine of all of that. Alternatively, we could work out that thing first. Okay, maybe let's do that, that's a bit nicer. 16.907 times sine 75 divided by 32, and I get 0.51035. And let's do inverse sine of that. And I got 30.687, or to one decimal place, 30.7 degrees. Again, I'm going to store that just in case I need it in a later part of the question. I've just realised I forgot something, because that 30.7 of course was this thing here. And what I said I was going to do is then find x, okay, which I haven't yet done. So hold up. Now I need to do 180, subtract 75, subtract that 30.7. And that gives me 74.3 degrees. So watch out with that there. I almost made that mistake that I said to be careful about. Okay, so now we want to find the area of this quadrilateral, and I think the best way to do that is by splitting it into two triangles and using the area of the triangle formula. The area of the triangle formula is a half AB sine C, and we're using side, angle, side for each of them. I'm going to do this one first and then this one. So for the first one, area is a half AB sine C. So that's a half times the two sides either side of that angle, so 16 times 19 times sine 57. I got 127.48. I'll do it to two decimal places for now. Let's do the same thing for the second one. And again, I'm going to do side, angle, side. Well, I don't have this side, so I need to use these two sides and that angle there. So that is a half times 16.907 times the other side, 32, times sine of that 74.3. So let's do that, hopefully using as many unrounded answers as possible. So the more of those things that you have stored, the better. So half times 16.907 times 32 times sine, and again I want that stored one. And with the stored exact values I got 260.44, and now all I'm going to do is add those two things up. And I get 387.9, or to three significant figures, 388 meters squared. Okay, last part of this question, find the shortest distance from B to AD. Okay, let's get this diagram again. And first of all, let's show the distance that they're referring to. The shortest distance from B to AD will be where this line makes a right angle with this one. So we get a right angle, whoops, we get a right angle here. Okay, so what I'm going to do is I'm just going to redraw that little triangle there. So this thing here is 57 degrees, that's at A. This thing here is 16, this is B, and this here is a right angle. And we want to find that shortest distance, well that's this length here. This is what I'm trying to find. So these are quite common parts of these questions, and they look tricky at first, but when you draw this triangle, hopefully you realise that this is just a SOHCAHTOA question. Okay, here I have the opposite side and the hypotenuse. So that's SO. So here we go, I'm going to write sine 57 is equal to the opposite side, x, over the hypotenuse, 16. So that means that x is equal to 16 sine 57, and then I'm going to put that into my calculator, 13.4. So even though that was the last part of that question, it was probably the easiest one of all of those. So just because you can't do parts A, B, C doesn't mean you should skip part C and part D as well. I wouldn't be surprised if you get a speed time graph as well. We're asked for the deceleration of the car between 10 and 13. Okay, I'm going to use the formula for acceleration, which is V minus U divided by T. So our final speed is 0, our initial speed is 8, divided by the time, which is 3. So that is minus 8 over 3 meters per second squared. Now because it asks for the deceleration though, we don't want that minus sign in. If the acceleration is negative, that's a deceleration, so let's just write it as 8 over 3 meters per second squared. Next, they want the total distance travelled. Now hopefully you know that the distance travelled is the area, so we're going to work out this area. You could do it as a rectangle and a triangle, but the easiest way is again to use the area of a trapezium. So I'm going to do a half times the sum of the parallel sides times the height between them. So 1/2 times, well the parallel sides, well this top line is 10 long, looking at the x-axis there, so that's 10 long, and the bottom side is 13, so 10 plus 13 times by the height, which I think was 8, yeah. So that's a half times 23 times 8, which is 92. Okay, so this is a bounds question, and we're going to use both the area and this length here. So the first thing we always do in these kinds of questions is write down the upper and lower bound of each of these. So for 55.2, that's correct to 1 decimal place. So the upper bound is 55.25 and the lower bound is 55.15. For the length, 9. Now that's correct to the nearest centimetre. So the upper bound is 9.5 and the lower bound is 8.5. So for the width, well, I know that width times length gives me the area. That means that the width is going to be the area divided by the length. And I want this to be the upper bound, so I want to make this as big as possible. That means the number on the top needs to be as big as possible. The number on the bottom needs to be as small as possible. So I want upper bound divided by lower bound. So the upper bound of the area is 55.25. But then I want the lower bound for the length, 8.5. So 55.25 divided by 8.5, and I get 6.5 centimetres. Okay, here we've got our regions on graphs question. We've already got the line x plus y equals 8. And it asks us to show the region defined by these inequalities. Let's start with this one, this x plus y is less than or equal to 8. With these, what we're going to do is we're going to test a point on one side or other of the line. I'm going to test the point here, 0, 0. So when x is 0 and y is 0, does this side of the line work? So 0 add 0 is less than or equal to 8. So is 0 less than or equal to 8? Yes, it is. So this is the side of the line that I want. I don't want the other side of the line. Now we are going to shade the region that we don't want. That's normally a better way to do these questions. Think of it as crossing out the bit that you don't want. So there we go. That's that region done. Now we're going to do the line x equals 2. Okay, and it's greater than or equal to, so again it's a full line that we're going to do here. If it was without the or equal to, we would use a dotted line. So there's my line x equals 2. I want x is greater than or equal to 2, which is on this right hand side. Okay, because here's x equals 3, 4, 5, right? So now I'm going to cross out the other side, cross out the left hand side. Here we go. Now finally we want y is less than or equal to 3, so let's draw a line at y equals 3, which looks like that. I want y is less than 3, less than or equal to 3, so I want the lower side of this line, so I'm going to cross out the top. And then we're going to label the region really clearly. Often we use an R to label the region. Now this is an unusual one because often it's the little triangle bits left, but they were being a bit tricky here. It's actually this lower trapezium shape that we wanted here. I wouldn't be surprised if you got another few sequence questions, because the sequence question were quite easy on the non-calculator paper. So let's have a look at this. Now I'm not immediately sure what kind of sequence this is, so I'm going to first of all write the first difference down and see if that helps us. So here I've got plus 7. Next I've got, what's that, plus 19 is it? And then 7, what's that, plus 37. And then, is that 52? Let's see if the second differences give us something. If they don't, then it's a different type of sequence that we've missed. So here I'm adding on 12. And here I'm not adding on the same thing. Here I'm adding on 18. And here's something else again. So that means it's not the second difference. So that means that if those second differences were constant, it will be a quadratic. It's not. Which means the only thing it can be is either a cubic or a geometric one where we multiply each time. So there's nothing that I can multiply by each time to end up with these numbers, so I think it's got to be cubic. So what I'm going to do now is write down the cube numbers. So n cubed, well, that's equal to 1 when n is equal to 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 times 4 is 64. And 5 cubed is 125. Now, all I'm going to do now is look for something to add or subtract, and if you spotted it, it's actually quite straightforward. All we need to do to each of these is add 7. N cubed add 7 gives me 8, 15, 34, etc. So for cubic sequences, I would only expect it to be add or subtract a number. I wouldn't expect it to have n cubed plus 3n or anything like that. Okay, for this next one here, with fractions like this, it is often best to consider the top and the bottom separately. So let's look at these numbers on the top first. 2, 3, 4, 5, 6. Okay, well, they're going up in ones each time. Okay, so look, plus 1, plus 1, plus 1. That means it is like the 1 times table, so n. And all we're doing each time to the 1 times table is we're adding on 1. So the sequence for these top numbers is just n plus 1. So we've got those top numbers done. Now let's have a look at the bottom numbers. 1, 4, 16, 64, 256. Okay, well, hopefully you've spotted what's going on here. We are multiplying by 4 each time. So that means that it looks like this, 4 to the power of n. Okay, if I do 4 to the power of n, that gives me 4 when n is equal to 1, 16 when n is equal to 2, 64 when n is equal to 3. So you can see there's a little bit of a problem. So what I want to do with this n is I don't want to get 4 here, I want to get 4 as the second one. So instead of 4 to the power of n, I want 4 to the power of n minus 1. Because then when n is equal to 1, 1 take away 1 is 0, and 4 to the power of 0 gives me 1. When n is equal to 2 for the second term, 2 take away 1 is 1, so we get 4 to the power of 1 is 4. For n is equal to 3, 3 take away 1 is 2, 4 squared is 16. So n plus 1 on the top and 4 to the power of n minus 1 on the bottom. I would definitely expect there to be something on straight line graphs. Let's just plot these 2 points roughly where we'd expect them to be. So minus 5, 8 and 7, 2. And we want the length of the line connecting these two. You could do this using a formula, but actually what this is it's using Pythagoras. Okay, so what is the distance between 8 and 2? Well, it's 6. What is the distance between minus 5 and 7? It's 12. So we're going to do the square root of 6 squared add 12 squared. Some of you are used to this formula. Okay, 7 minus minus 5 all squared plus 2 minus 8. And sure enough, you can see that this gives me 12 squared and minus 6 squared, or just 6 squared. So it gives me exactly the same thing. So that's 144, add 36. So that is the square root of 180, which, maybe let's leave it in third form, is 6 root 5. Part B wants the equation of the line that is perpendicular to AB and passes through the point minus 1, minus 3. Okay, so if it's perpendicular to AB, let's first of all find the gradient. Let's call this point here x1, y1, and this point here x2, y2. And for the gradient, I want y2 minus y1 divided by x2 minus x1. So 8 subtract 2 divided by minus 5 subtract 7. So 6 over minus 12. So the gradient of AB is negative a half, but I want perpendicular to AB. So we want the negative reciprocal of that. The negative reciprocal of minus 1/2 is 2. So our gradient is 2. I can already write y equals 2x plus c, and now we just need to find what c is by substituting in a point that the line passes through, which is minus 1, 3. So 3 is equal to 2 times minus 1 plus c. Then let's add 2 to both sides. And I get that c is equal to 5. So there we go, we've got our c, so that means that y is equal to 2x plus 5. There will almost certainly be a question on similar shapes in some way. Now, the way I always speak to my class about this is remembering that we have a linear scale factor, an area scale factor, and a volume scale factor. So we are told that the volume of the model is 12 and the volume of the statue is 40,500. So what I'm going to do to find the volume scale factor is do 40,500 divided by 12. That gives me 3,375. Okay, that's the scale factor for volumes. That doesn't mean it's the same scale factor for these other things. Okay, for the linear scale factor, the normal scale factor, I need to cube root this. So that's what I'm going to do now. The cube root of that, and I get 15. If you wanted to find the area scale factor, now I don't need it here, but for the area scale factor, we square that. So that would be 15 squared, or 225. So if you know the linear scale factor, you square it for the areas, and you cube it for the volumes. This is the only one that I needed here. Now if I know that the model had a height of 4 centimeters, I need to times it by that linear scale factor. So 4 times by 15, which is 60 centimeters high. I would definitely expect there to be a question on composite and inverse functions like this one. So first of all, let's do h of 3. That means we're replacing the x with a 3. So h of 3 is equal to 4 to the power of 3. So 4 to the power of 3 is 64. fh of 3. So that means doing f of h of 3, and we've already done h of 3. h of 3 was 64. So that means f of 64. That's what we're going to do. So that means I'm going to put 64 in the place of x in this function here. So 2 times x, or 2 times 64, take away 1. 2 64s are 128, subtract 1 is 127. So nice easy 1 mark questions there to begin with. The next one says solve the equation gf of x equals 0. So first we're going to need to find gf of x. Now gf of x is the same as g of f of x. So what I'm going to do is I'm going to start writing g, but anytime I have an x, I'm going to replace it with f. This is what I mean by that. So here, instead of writing x squared, I've just put some brackets there, squared, plus 2, and then there's another x there. And in these brackets, instead of having x, I'm going to put f of x. So f of x is 2x minus 1. What I'm now going to do is I'm going to expand and simplify this. So 2x minus 1 all squared. Careful, remember that means we need to do first outside, inside, last for that one. Okay, we'll do that in a moment. Let's expand this one here though, that one's a little bit easier. 2 times 2x is 4x. 2 times minus 1 is minus 2. Now let's expand this one. Firsts, outsides, insides, lasts. So 4x squared minus 2x minus 2x. And minus 1 times minus 1 is plus 1. And then add that 4x minus 2 from before. Right, let's simplify all of that. So I get 4x squared minus 2x is minus 4x. Plus 4x is 0, so those all cancel out. Then I've got plus 1 minus 2, which is just minus 1. So there we go, we found what g(f) of x is. It's 4x squared minus 1. Now I want to solve this equation when that thing is equal to 0. Okay, we could do that maybe by adding 1 to both sides, dividing by 4, and then we're going to square root. And you should notice that here there are two possible answers. When we square root 1 over 4, well, your calculator might just tell you it's a half, but you should also realise that it can be negative a half. Negative 1/2 times negative 1/2 also gives us plus 1/4. So a half or minus a half. Part C here says p to the power, so inverse of p equals f of x. Okay, let's find the inverse of p. Oh, we're not given anything about the inverse of p. Oh, I see what that means. So the inverse of p is equal to f of x. So let's first of all write down that, then p minus 1 of x is equal to f of x, and f of x is 2x minus 1. Okay, so if we have the inverse and we want to find the normal function, well, we do exactly the same thing as if we were finding the inverse. So what I'm going to do is I'm going to write y equals 2x minus 1. I'm going to find the inverse of this by changing the subject to x. First, we're going to add 1 to both sides. Y plus 1 equals 2x. Then I'm going to divide both sides by 2. So x equals y plus 1 divided by 2. Then I'm going to switch the x's and y's. Okay, so then I'm going to change this y not to p minus 1 but p of x this time. So p of x is equal to x plus 1 divided by 2. Now sure enough, if you were to find the inverse of this, you would find that you get this thing here, 2x minus 1. If you find this a little bit confusing, there are lots and lots of questions on composite and inverse functions on that section of my website. There will almost certainly be some kind of Venn diagrams question. This first part, we're going to need to fill this in. What I always tell my students is start from the middle of that Venn diagram. Now there's not really anything that we can put in the middle, so what I'm going to put for now is I'm going to put an x here. That means that this part, the glasses part, that must be 28 minus x. Whatever that thing is here, if it's 3, then that means there's only 25 left in this bit. Okay. For this side, that's going to be 13 minus x. And this one here, we know that that one's 4. Okay, so actually we can write that one in. Let's do it in blue there. That's 4. Now I'm going to set up a little equation here. All of these things added up must make 40. So let's write that. 28 minus x, add 13 minus x, add 4. That has to add up to 40. Let's simplify the left hand side. So 28 add 13 is 41, add 4 is 45. minus x plus x is nothing, and then minus x again, so 45 minus x equals 40. You could probably figure out what x is already, but just in case you can't, I'm going to subtract 45 from both sides. I get minus x equals minus 5, times both sides by minus 1, so that means that x equals 5. So that's 5, that's 28 take away 5, which is 23, that's 13 take away 5, which is 8. Let's just double check those numbers work. 23 add 5 is 28, add 8 is 36, add 4 is 40. So yeah, those are correct. Use set notation to describe the region that contains a total of 30 students. So which region would that be? 32 students. So 23 add 5 is 28, add that 4, that makes 32. So I want everything apart from that section there. So how could we make that section there? Okay, well what we could do is we could do G and that together with only the outside bit would be one way I can see we could do it. So the union of G with the outside bit would be G union D, but not that. Is there a simpler way to do that one? I'm not sure if that is. That's the easiest one I can think of, but maybe you can comment if you can spot an easier way to do that one. I'm sure there's another way we could potentially do that. But that definitely covers all of that area because that's all of G, and G union D would be all of that bit, and then not that is just the outside bit there. So that definitely works. Maybe you can spot an easier way. If you do, comment below. Okay, this Venn diagram shows blah 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 blah. We want to find the number in B union F. Okay, let's shade that. So B union F but then the intersection with not H. So let's use a different colour to now shade not H. That's everything outside of the H circle. And we want the intersection. So that means the bit that's shaded twice. Now the bit that's shaded twice is this bit here. Okay, so I'm just going to clear everything away and just outline that bit there. So it's this, there. So that 2, that's 7, and that's 6. So the number of elements, that's what that n means, is 2 plus 7 plus 6. So there are 15 elements in that set. Okay, and they've really made these quite tricky actually. So now we want P union Q intersection R, but then the complement of that. So let's do that Q intersection R and the complement of that first. So Q intersection R is this. So the complement of that is everything outside of that. So I'm now going to shade everything outside apart from that little bit there, which seems like a lot of the diagram. And then I also want to shade P. Okay, so basically we want everything shaded apart from that tiny little section there. Okay, so if you wanted to now then do it a little bit neater, shade everything in, including this little bit in the middle. And the only bit we want to leave is that little centre bit there. That's starting to look a little bit messy, so okay, let's leave it like that. Tricky, those questions. Well done if you got them right. So here, to solve these simultaneous equations, because one of them is quadratic, we can't do them by elimination. We're going to do them by substitution. So what I'm going to do first of all is take this one and rearrange it. So I'm going to subtract 3x from both sides to give me y equals 11 minus 3x. And I'm going to substitute that into the other equation. Okay, so when I do that, I get x squared minus 2 times y, which is 11 minus 3x, and that is equal to 18. Let's expand those brackets. Minus 2 times 11 minus 22, minus 2 times minus 3x is plus 6x. Okay, so now we've got a quadratic. We need to get it all onto one side. So x squared plus 6x minus 22 subtract 18 is minus 40. Okay, now does this factorise? So we're looking for two numbers that add to give 6 and multiply together to give minus 40. It does factorise with x plus 10 and x minus 4. If it didn't factorise, not to worry, because this is a calculator paper, you could use the quadratic formula to solve this. Okay, but here this one does, so I get my two solutions, x is minus 10 and x is equal to 4. Now I'm going to substitute them in to that first equation to figure out what y is equal to. So first of all, let's substitute in x equals minus 10. So y equals 11 minus 3 times minus 10. Minus 3 times minus 10 is plus 30. So here we're going to get y is equal to 41. And when x is equal to 4, let's do the same thing. Y equals 11 minus 3 times by 4. 3 times 4 is 12, so 11 minus 12 is minus 1. So there we've got our two coordinates. We've got when x is equal to minus 10, y is equal to 41. And when x is equal to 4, y is equal to minus 1. Last question is a 3D Pythagoras or trigonometry question. So we've got a cuboid measuring 6 by 3 by 2. We want the sine of angle PAN, which is the angle that they've shown there, that one. Okay. So to find that, I think we need some of these measurements. Let's first of all try and find out what the length of this line is here, A to N. Okay. So I'm going to redraw that triangle that I've just drawn as if I'm facing right down from above. Now that there, if you were looking down from on top, that there is actually a right angle. Okay, so there we go, there's our right angle. That's A, that's N. Okay, and that's the right angle there. Let's fill in the measurements that we've got. This thing here is 6 centimeters. And this length here is the same as that, so that there is 3 centimeters. And I think to know this angle, it's going to be useful to know what this length is here. So let's find that. Let's call it x. And to find that, I'm going to do a bit of Pythagoras. So x squared is equal to 3 squared plus 6 squared. So that's 9 plus 36, which is 45. So x is the square root of that, root 45. I'm going to leave it like that for now. Okay, let's just put it on the diagram, square root 45. I know that simplifies as a surd, but don't worry about that just yet. So now let's have a look at this triangle here. Okay, so that one, and that one. I think we've got enough information to actually figure this out now. If I just draw that triangle over here, it's useful to do these little sketches. So at the bottom there, that's also a right angle at N. So we have A in the bottom left, P up here, and N here. And the lengths that we've got the bottom is root 45. We know what Pn is. It's the same as this side here. It's 2. Okay? And we want the sine of the angle. This angle here. Now for the sine of that angle, let's think about it. If we think of SOHCAHTOA, which two sides do I need for sine? Well, I need the opposite and the hypotenuse. Well, I don't have the hypotenuse, so we need to work that one out. So let's do that. Let's call it y this time. So y squared equals 2 squared plus the square root of 45 squared. Well, 2 squared is 4, and the square root of 45 all squared is 45. Right, and that's why there was no point in simplifying that there. 4 add 45 is 49. So y is the square root of 49, which is 7. Excellent, so we've worked out that. So now the sine of that angle, PAN, is equal to opposite divided by hypotenuse, which we have now got. The opposite is 2 and the hypotenuse is 7. So the sine of that angle is just 2 over 7. That's it, that's the last question. Good luck with your paper, whether it's tomorrow or if you're looking at this on the morning of the exam. I wish you all the best. And hopefully see some of you next year for your AS exams. Good luck. Bye now.